Hi guys, and welcome to my new blog post 26. And in this blog post I'm going to discuss about the concept of the universal set. So let's start. So basically when we talk about a universal set, it means we are talking about a set that has elements of all related sets without any repetition of elements. So uh, it is normally a set of all sets, and we can say this like the universal set is basically the reflection of its name. A universal set in general terms is basically defined as the set of all objects under consideration, as depicted in the following diagram. A universal set is basically a set that contains all elements or objects of other sets, including its elements. So it is normally denoted by the letter U. So the exact definition of U is basically based on the context of the theory being considered. The elements that normally contained in universal set, which is U, may vary according to the context of the sets being stated. For instance, we might describe U as the collection of all living things on the planet Earth. In this case, the set of all the mammals, or set of all the reptiles, or the set of all the birds becomes a subset of U. Similarly, we can say that the set of all countries in the world is also universal. When we talk about the set theory or the universal set in mathematical terms, the universal set is basically the set of whole numbers. Depending on the context, this set may also be the set of all the shapes or set of all the second degree polynomials and many more. Since a set is a collection of various entities with a common property, the universal set is the collection of all elements relevant to a specific subject. It could be anything like real numbers or a deck of cards to the word inhabitants, uh, and much more. Elements in a universal set are not repeated elements, so all these elements are distinct and unique. So let us go through a example. So consider like we have three sets, namely X, Y, and Z. So these sets actually have various numbers, right? Like the set X contains 2, 4, 6, 8, Y contains 3, 7, 9, 11, and Z also contains 4, 8, and 11. If you notice over here, you can see like there are few numbers that are repeated among the sets. Like for example, X and Y actually contains uh, nothing unique right now. Sorry, nothing repeated right now. But Y and Z actually contains some elements which are being repeated. For example, uh, Y and Z have 11, and X and Z has a common element which is actually 4. So when we actually talk about universal set, it means that I am talking about uh, all the numbers which are actually present in this set uh, will merge into a one set and will create a one universal set. So that set would be like 2, 3, 4, 5, 6, 7, 8, 9, 11, and the repetition actually shall be removed, uh, which will be uh, which will create a distinction among the set. So here sometimes we can see that uh, we know that like the universal set contains all the elements of the given sets. Thus the universal set of X, Y, and Z is here, uh, like which I have shown showcasing you here. So we can see from the solution like that these elements of sets X, Y, and Z are completely available in the universal set U, and also there are no elements that are repeated in the universal set, and all the elements are unique. By the way, in this universal set U, there might exist another set, for example A, and like since it's not showcased over here, it might be over here. It can be placed over here. But if we say that if there is a set U, which is actually a universal set, then there are three further subsets that are created from this universal set, which are actually x, y, and z. So uh, this is the basic example of the universal set. There is a one distinction that is actually required to be discussed, like there is a difference between universal set and a union of set. So for this I will discuss this difference in my next video. Okay, so I hope so you have understood the concept.